gets a packet? Wow. Great. Chen. So now this is something you have never seen before. Pretty much everything we learned before is review up to now. So there's 2 tests left in this quarter. Some of you are getting close to the Mexican border too. But then now you gotta climb a very high mountain. This is tough, this chapter. Like I told you, one of the smartest guys ever from Iolani in math, he's at Olin right now. He got a 60 on his test. He claimed to have a headache though. Still. Roy did Ongi.
How would he go?
Okay, now you gotta wait. Oh, Jonathan Higa, I never taught him.
I think he would have.
Well, 98 or 100 probably, right?
Yeah.
Like he probably learned it when he was in elementary school, probably. Okay, what are parametric equations? Okay, we're going to start in 2 dimensions first. Parametric equations are equations that give you the position of a particle traveling in either 2 or 3 or higher dimensions in terms of a third variable. Normally that third variable is going to be time, right, you guys in physics? But it doesn't have to be time, it's just a third variable. But for thinking conceptual purposes, we think of it as time, it'll make it a lot easier. Okay, so let me give you an example. X equals t plus 1, y equal 2t minus 1. And why don't we just say t is greater than or equal to 0, because in physics there's no such thing as negative time, right? We'll just think of t as time, but like I told you, t doesn't have to be time, it's just a third variable. Okay, how can I tell we're working in 2 dimensions here? Because you only got x and y. Now, of course, you guys in physics, you guys know only 1 dimension, yeah? Particle moving on a line. Saying Yoshina or Yodomari, I know you guys are in physics. Didn't you guys look particle moving on a line? And then you had to compute like velocity, acceleration, the distance traveled, the net displacement, and things like that. When is it moving to the right? When is it moving to the left? When is it speeding up? When is it slowing down? So you guys are going to take physics next year, you're going to dominate, if you can even remember this. So that would be that, just a particle moving on a number line, but now we got a particle moving in the Cartesian plane, and then if we add z, then you got a particle moving in space. See, once you add this time factor in, then that's how you compute velocities and acceleration, once you're given the time. Okay, so let me show you how it works. So everybody got to see this the first time. Here's the Cartesian plane. Now when t is 0, now if you want to make a chart like this is the way the babies do it. Okay, when t is 0, I guess you have to see it once, right? When t is 0, what are the x and y coordinates of the particle? Just plug in 0 there. 1, and then if I plug in 0 there, you gotta be joking. If you cannot plug in 0, just give up already. 1, -1. So that means the particle's initial position, you guys know what initial position means, right? Like in physics, initial velocity, initial acceleration, initial position. That means where it starts when t is 0. So when t is 0, the particle is right there. This just tells you the position of where the particle is at certain values of time. Okay, now what about when t is 1? So let's assume t is measured in seconds. 1 second later, where is the particle? Plug in 1. 1 plus 1. Oh gosh, you guys are on it today. 2 times 1 minus 1. 1. So now the particle's at the point 2, 1. Right there. So 1 second later, the particle's there. Okay, now what about after another second? what about at 2 seconds? Where's the particle located? Well, if I plug in 2, you get 3, 3. So 3, 3. So at 2 seconds, the particle is there now. Are you getting the hang of it? Okay, what about at 3 seconds? Where's the particle? 4, 5. Oh, Mr. Park, the x's go up by 1s and the y's going up by 2. Duh! Okay, whatever. 4, 5. So here is the particle at 3 seconds. Okay, look, are you guys catching up? Or one more? Okay, one more then. What about at 4 seconds? What is the location or the position of the particle? Plug in 4. 5, 7. So over here. So it kind of looks like the particle is traveling in a straight line, yeah? Kind of. Does it look like it's traveling in a straight line? How do we know it's traveling in a straight line? It looks like it, but maybe not. How can you? Because all we know is the particle is here at t equals 0, and then it's there at t equals 1. How do you know in between it doesn't do this? Right? No. No, because there are some graphs that do crazy things like that, as you're going to find out. Right now we're just looking at the baby one. We're in the boom right now. How do you know the particle is going in a straight line and not doing some weird things in between? Because all you know is the particle is here at 0 and there at 1. How do you know what it does in between? Oh, you want to play that game, period 3? How do you know the particle is traveling in a straight line? How do you know it's not doing weird things? Like, how do you know it's not oscillating back and forth like that, like a sine curve or something? Okay, this is how you do. This is what you do. What we do is we eliminate the parameter, and that will give us the rectangular equation of the graph that it's traveling on. In other words, we're going to get rid of the t. Okay. So the most common technique for eliminating t is solve for t in one equation and then plug it into the other. It's quite simple. So if you solve for t in the first equation, what do you get? T equals x minus 1. Plug it into the second equation, and then you get y equals 2 times t, which is x minus 1 minus 1. And then if you simplify that, you get 2x minus 2 minus 1, which is 2x minus 3. This is the graph that the particle is traveling on. And now we know that's a line, right, from algebra 1. Yeah, and there, this is the line right here. Right, y equals 2x minus 3. Yeah, but see, it's not enough to know the graph that it's traveling on. You gotta know how it's traveling on that line. Okay, so, you know, at the end of this year, we're gonna take an achievement test. You know, at the end of every math class, you take a test, a multiple choice test that tells you how much you've learned. Well, you're gonna have a problem like this, and they're gonna ask you, okay, they're gonna give you this problem, parametric, and they're gonna ask you, what is the path traced out by the particle? And it's gonna be multiple choice. A, line. B, segment. D, ray. D, circle. E, parabola. So what's the answer? It's a ray. Because look, the particle starts here and it goes like this. And it keeps on going forever. Isn't that a ray? Which is different from a line, which goes like that. Or a segment, which is just that, right? It's a ray. What's a ray? Try, what's happening this semester? This is a line. This is a ray. That is a segment. Okay. We got this on video now. So do you see how all of this works? So if you look at your homework tonight, there's a whole bunch of parametric equations. What you have to do is you have to tell me first of all, what is the rectangular equation that the particle is traveling on? Okay, this is like the test. Okay, you're not going to get anything this easy. This is just to start with, okay? So you write this down on your paper, you get 4 out of 8 points. Then you have to tell me how the particle travels on it for the other 4 points. would say the particle travels on the line y equal 2x minus 3. The initial position is at the point 1, negative 1, and then it travels up the line with a constant velocity. Or if you don't know the difference between velocity and speed now, you can say constant speed then. How do you know it's constant? Because you travel from here to here in 1 second, and you're traveling the same distance every second, right? That's constant. It doesn't change. In fact, what is your speed here, guys, in physics? Oh boy, look. This is a right triangle. If this is 1 and that's 2, the hypotenuse is root 5. So the speed is root 5 units per second. It travels root 5 units every second, right? Ooh. Okay, that's a line, people. Now, you see this chart I made right here? If you need to draw this chart, draw it. Now, normally when you first learn it, you draw a chart, but after a while, just do it in your head, right? Okay, are we ready to kick it up a notch? Well, it doesn't matter, we're kicking it up a notch now. Okay, here we go. And then what's going to happen is the problems just get tougher and tougher and tougher as you go. So that's why, can you see that you got to know all your graphs? Because you're going to be drawing graphs. That's what's happening in this chapter. Okay, x equals cosine t, y equals sine t, and let's say t is greater than or equal to 0 again. Okay, again, we're in 2 dimensions here. Now normally, okay, the first thing you got to do is you got to give me the equation of the rectangular equation of the graph that the particle is traveling on. So normally you would solve for t in one equation and then plug it into the other. I mean, you could do it here, but then it's kind of messy, right? Because look, t equals x over cos. Plug it into the other equation, so y equals sine of x over cos. The s's cancel out, and so you get in x over cos. That's dumb. If you were to solve for t, it would be t equals cosine inverse x, and you plug it in there. And you could do it, and you can draw the triangle and figure it out, right? But when you have trig functions, it's a lot easier to use identities. You know, so now you got to know all your identities and trig values. Woo! Okay, now what identity do we know that involves cosine and sine? The most important one. Cosine squared plus sine squared is 1. So what you do is you square both of these equations and you get x squared equals cosine squared t, y squared equals sine squared t, and then what do you think I'm going to do? Add or subtract them? You add, because we just said cosine squared plus sine squared is 1. So if you add the equations, you get x squared plus y squared equal 1. Hey, you're somebody. You're a circle. You just got 4 points. So we know the particle is traveling on the circle. It's a circle, center at the origin, radius 1. So you're going to draw it in a dotted line. Okay, now you have to tell me how the particle is traveling on the circle. Like, where does it start? How does it travel on the circle? Because you're going to find, you've got some crazy problems. You're going to find out. Okay, tell me, where is the initial position of this particle? When t is 0. So, do you want to make the chart, or we're past that already? Then why did I try it? If t is 0, what is x and y? So now you got to go back to your original equations and start plugging in like a mad dog. Plug in 0. 1. See, this you can do in your head, right? So here is the initial position of the particle. The particle starts at 1, 0. Now, which direction does it go? Does it go clockwise, counterclockwise? Because sometimes, some graphs go like this, you know. It just keeps on going back and forth like that. Or sometimes it goes, no, crazy stuff. No. This one's not that crazy, as you're going to find out, but later on, it's going to get crazy. Okay, well, how do I figure out where the particle goes? You got to plug in another number, so what do you think? 6, pi over 4, pi over 3, pi over 2. What do you want to plug in? Okay, pi over 2, that's a good choice. So you plug in pi over 2 and you get? Oh no. See, if you don't know your trig values, you're doomed. How are you going to graph? Pretty much every single one, I'll tell you right now, pretty much every single one got trig in it, okay? And if you kind of plug in quadrantal angles, what pair do you have? These are quadrantal angles. 0. Okay, let's see. So now, oh, the particle's over here now. So you might think the particle, oh, it just travels counterclockwise then. Maybe, maybe not. So maybe we've got to plug in some more. Okay, next. Okay, pi. -1, 0. So here is the particle at t equal pi. What about a, see, maybe we do need to make this chart. Maybe this is the first, what's happening here? -1, 0. 3 pi over 2. 0, -1. So that's down here. And then why don't we finish it off at 2 pi? 1, 0. And then you know how trig functions work, right? It's periodic, right? So what's happening? The particle starts here, it goes like this. And it just keeps on going, right? Because t is greater than 0. And you guys in physics, what is this? Especially if you're taking the AP exam, you better know what that is.
Uniform circular motion.
There you go, uniform circular motion. How do you know that? You're not even in physics. Hey, really? I put that on the notes.
Yeah.
Wow, I'm more thorough than I thought. Yeah, that's called uniform circular motion. So, true or false, this particle is traveling with constant velocity. So,
True.
does it travel with constant velocity? Oyadamari? Why not? Aha! See? See, that's the difference between the physics people and the non-physics people. Velocity is a vector quantity. It's a vector. See, like over here. Yes, the speed is, okay, true or false? Does it travel with constant speed? Yes, the speed is constant, but the velocity is not. See, because like right here, this is the velocity vector. And when it keeps going, okay, there it is now. There it is now. Can you say that that vector is the same as that vector? No, it has the same length, but it's pointing in a different direction. So it has a constant speed, but not constant velocity, because velocity is a vector. That's why you got to know the difference between scalars and vectors. That's why we did last chapter. And you're going to have to know last chapter for this chapter too, believe it or not. Woo! Okay, what time is it? Because I don't know if I want to teach you how to graph today, because we've got to go over the test too. Okay, take out your calculators. You know your calculators can graph, right? I'm going to teach you how to graph because that's how you're going to check your homework answers anyway. Okay, now we are graphing parametric equations. So if you have a TI calculator, first thing you have to go press the mode button and go into parametric mode. You got par, func, pole, seq. Par is parametric, func is function. No, it's func first. What's first? Func. Func is function, par is parametric, pole is polar, and seq is sequence. Okay, go to parametric mode, press the Y equal button, and what do you see? You see x1 of t equals y1 of t equals, so basically it only can graph 2 dimensions. That's all it can do. I'm going to show you your iPad though, can graph 3 dimensions. Okay, so x1 of t is, type it in, cosine of t, sine of t. And Mr. Park, where's the t button? The variable button, x, t, theta, n. I keep telling you. If you're in function mode, the x comes out. If you're in parametric mode, the t comes out. If you're in polar mode, the theta comes out. If you're in sequence mode, the n comes out. Okay, and then, if you want to initialize, set it back to the default settings, what did I tell you to do? Zoom, standard. Zoom standard puts everything back to the default setting. Do a zoom standard first, and then if you want to change the window, you can. Now the prism people, you go into graph mode. You guys already did that? And then what do you press? Exit? Who has prism? Zhang, where's your graphic calculator? No, you can't use that on the AP exam or on the SAT. You cannot. What's happening, Zhang? Okay, here I got some prism people. Okay, so press, okay, just type, select type, parametric. There you go. And then you gotta delete all those things. So enter, exit, delete, yes. How did you get all those things in there? Okay, type, parametric. Okay, now type in those things. Cosine t, equal to t. Yeah, so they have the t here, huh? You have an independent. And you put the parentheses too around the argument, yeah? Now, the normal settings, this is for TI, I'm not so sure about the Prism, but the default settings is t is always going to go from 0 to 2 pi unless you change it. Okay? 0 to 2 pi. So if you graph it on the TI, this is all you're going to see. If you want to see more, then you got to go like 0 to 8 pi and then go. Like that. What about the Prism people? Did it just go one time around? Okay, so it's 0 to 2 pi. That's default. So if you want to change it, you got to change it. Okay, now let me show you how to graph this on the iPad. Saying you gotta have your graphic calculator now because you gotta use iPad on the test either. Or quiz. Okay, so on the iPad, you go into your Pocket Cast. I guess you guys have the light, yeah? New entry. Now remember I told you, when you graph, you don't have to type in the y equal or the r equal if you do polar. So same thing with parametric. You gotta do this. You gotta type it in like this. Left bracket, cosine t, comma, sine t. Right bracket, go, and then thing will graph that. Graphs it super fast though. Even faster than that thing. Okay, try that.
Could you repeat that? I just opened it. I have hard time finding it, that's why.
Well, how many apps do you have on there?
Oh no, it's in one of those folder things.
Why would it be in a folder? Okay, whatever. Okay, new entry, and then just type that in. Oh no, new entry, and you got to select plot, and then type that in. Yo, but Mr. Park, it doesn't look like a circle. Yeah, it's because the scaling on the x and the y axis are different. So what can you do? See, just use your fingers and change it, man. No. Yeah, now it looks like a circle. Saying, did we get it? Okay, but the good thing about the iPad is you can graph 3 dimensions. Okay, don't do this yet. Don't do this yet. I just want to see how good you are. Okay, now what happens if we do at a 3rd dimension? Now we should be experts at 3 dimensions, yeah? Here. No, don't do it yet. Don't do it. I want to see how your brain is thinking here. What is the graph? What is the path traced out by the particle? Give me a name. What is the path? So in the xy plane, it's just doing this, right? That's all it's doing. Uniform circular motion. Okay, but what happens when you add a z coordinate now? T. That means as t gets bigger, z gets bigger. So what's happening is the graph looks like this, like. Like that. the notes too? It is for real. Oh my God. Okay, so if you want to graph it three-dimensionally, this is what you do. So you go 3D plot, cosine t, sine t, t. Now the problem with this is, I think, to get the t, you got to go to the ABC menu, yeah? Because when you do the three-dimension thing, the t is not there for some reason. I don't know why they would do that. Look what time it is. I could. Oh,
Do you need a period after the comma? I mean, a space after every comma.
wait, let me look. No. Where's that coming from?
Because like in English, you need a space.
This is not English. This is math.
Not,
Really, when you type your papers, what if you don't put a space after the comma?
then it has that red line. So then I just.
No, but what about the teacher? Who cares if the red line there is there? What about the teachers? What did the teachers say?
You don't look that closely.
Okay, anyway, do you guys see the helix? And then you can move the graph around, right? With your finger. I like the iPad better. Yeah, but too bad you can't use it on the AP exam or the SAT, right? Or any test, because you can just take a picture and send it. Okay, we got to do one more, even though we're going to run out of time for the test. Too bad. We'll discuss the test later. We got to do this one, otherwise some of you just going to get blasted out of the water on tonight's homework. I'm not doing it anyway. You guys are just so shameless. Okay, here is a medium problem right here. Okay, what procedure should I use to eliminate the parameter here? Solve for t in one equation, plug it into the other? Or should I use trig identities? Yeah, we want to use trig identity. So, what identity do we know of that involves secant and tangent? Pythagorean identity, people. 1 plus tangent squared equals secant squared, right? If you don't know that, you're in trouble. Okay, so that means we need to square these things. So square. I wanted to do several more examples, but it's not going to happen today. Because you just have to keep seeing these over and over and over. There's really only like one lecture, you know. This is it, and the rest is just getting better and seeing different problems. Okay, now what do I do with these equations if I want to eliminate t? Do I add, subtract, multiply, or divide? You subtract. So x squared minus y squared equals 1, right? Secant squared minus tangent squared is 1, right? Since 1 plus tangent squared is secant squared. Oh, I got 4 points! We don't know this! See, that's the problem. You gotta know all the graphs. If you don't know your graphs, you're done for in this chapter. It's a hyperbola. Center 0, 0. So you go one left, one right, you make the box, remember? Here are the asymptotes. And since the x comes first, this is a left-right one, yeah? Okay, now, how does the particle travel in this hyperbola? See, it's not enough to know the graph, you gotta know how it travels on it. So where's the initial position? Plug in 1. Quick. Plug in 0. I just gave it away. 1. We don't even know secant 0 is 1. Cosine of 0 is 1, and you reciprocatize it, you get 1. 1, 0. The particle starts here. This is where t is 0. Okay, what's the next number I should plug in? Quick, so we can look at our test. No, pi over 2 is too far away. That's not good enough. Okay, pi over 4. Plug in pi over 4. Root 2, 1. So root 2, 1 would be about there. Okay, just for funsies, pi over 3. No, that's okay. We're just going to skip. Pi over 2. What happens when you plug in pi over 2? Undefined. Okay, now this is the tricky part. What happens when x or y or both become undefined? What does undefined even mean? That means you're dividing by 0, but then when you divide by a very tiny number, a number almost 0, what happens? It becomes very large, infinitely large. So what happens? This is what happens. The particle starts here. It goes like this. No, that's what it does. It just goes far away. When it hits pi over 2 though, it's undefined, so it's like infinitely far away. What happens is the particle, boop, it disappears. It disappears. And then what's going to happen now, it's going to reappear. But then you got to figure out where it's going to reappear. Okay, somebody tell me where it's, so just on the others, okay, as it's going up, pi over 4, pi over 2, disappear. Now on the other side of pi over 2, we're talking about time now, where's the particle? Think of your unit circle. Here's pi over 2. Just on the other side of pi over 2, what quadrant are you in? What's the secant and tangent of second quadrant angles? Negative and negative. So where is x and y both negative? In the third quadrant, so the particle reappears, but infinitely far away. So, and then it goes, and then at 3 pi over 2, it becomes undefined again, it disappears again. Now, just on the other side of 3 pi over 2, what are secant and tangent? This is fourth quadrant, that's why. What is secant and tangent in the fourth quadrant? Secant is positive, but tangent is, so where is x positive and y negative? In the fourth quadrant, so the thing reappears infinitely far away there, and then since it keeps on going, and it just keeps doing that over and over and over. Okay, quickly graph that on your calculator. And nobody better ask me where the secant button is, because there is no secant button. You got to go 1 over cosine. I only got 5 minutes left. I'll just pass back the test and you can look at it real quick.